Two blocks are shown on the diagram are at rest on a horizontal surface when a force P applies to block B. Blocks A and B have masses 20 kilograms and 35 kilograms respectively. The coefficient of friction between two blocks is 0.35 and the coefficient between the horizontal surface and block B is 0.3. Determine the maximum force P before A slips on B. Okay, so what we're going to do here is A1 is getting supported by R1, B1 in turn is feeling the force R1 down. A is 20G going down, B is 35G going directly down, and it experiences a force R2 supporting it. Okay, so if we draw them individually, what we could have here is A is going up at R1, 20G downwards. Now, it's coefficient blocks, okay. So A is going to slip on B. That means that A is technically going to be going right relative to B. Do you know the way we used to have the wedge questions where it's the acceleration of the particle relative to the wedge. It's not the overall acceleration of the particle. In the same way, although A is slipping to the left when compared to B's motion, what I'm trying to say it's relative to B. As if B were stationary, A is sliding off it to the left because of the force applied. Okay, so that's why we're going to have the acceleration going to the left. We'll call it A. Okay, and then there's a force. What's the force holding it in play? The force holding it in play is friction of A on B. Now, we're going to get B's point of view. And B's point of view is completely different to that of A's. Okay, so this particle B, and what it's going to be experiencing is it's going an acceleration P. Opposing this motion is friction of B on ground and this is the one that everybody would forget. The friction of A is also stopping it. Friction of A on B, and then R2 going upwards because experiencing force on the ground, and R1 going downwards. Okay, now in order for A not to slip off B, the friction between A and B must equal the acceleration of A. A and B have a common acceleration. It's the friction that connects A to B and drives it to the right. So they're moving together, okay? And if A is not moving, if this isn't moving or slipping, it means that its force to the left equals the force going to the right. Its slipping acceleration equals the friction. Its slipping force equals the frictional force, which is why it doesn't move. Okay? So what we're going to do first of all is statics. Now statics suggests that what goes up equals what goes down. R1 equals 20G, according to A, which would be correct. Okay? Now we're going to do force, going left to right. Now, 20A has to equal, force has to equal friction. 20A, its acceleration has to be equal to 0.35 times 20G. A therefore is 0.35G. Now, block B going up and down will be R2, which is going up, equals R1 going down, plus its own weight of 35G. You don't have to count in A's weight because A's weight is taken account of because of this here. Okay. R1. Now, we already know that R1 is 20G. R2 therefore is 55G. Now we're going to do the horizontal for block B. So horizontal for block B is going left to right, and what we're going to have is force equals. Now, force equals, what's driving it to the right is the force P. What's stopping it going is friction, and there's another element of friction also driving it that way. So what we're going to find is the force is mass by acceleration, which is 35A. It's going to be P minus 0.35 R1. Remember, friction is mu R. And then it's 0.3 times R2. And that's going to be P minus 0.35 20G minus 0.3 times 55G. Then it's going to be 35. Now what did we say acceleration was again? 0.35G. That equals P minus 7G minus 16.5G. Then we're going to bring the G's all to one side, and what we're going to find out is that P equals 35.75G, or 350.35 newtons.